Hey everybody, welcome to Bill Sky, the assembly guy, for yet another video on assembly language. What we're going to do today is we're going to take a look at simple arithmetic, addition and subtraction. This particular video is going to be on the Intel processor, the x86-64 processor. I'm going to be doing another video on the ARM RISC processor, but let's get to it. So I have a Linux up here and running now. This is going to work exactly the same with Windows. The code's no different. I'm just using a Linux because it's just a little bit easier. Maybe I should say a lot easier. And I'm going to go ahead and open up a 64-bit functions template. There you go. And let's rename that to x64 addition subtraction. And let's take a look at this. All right, so how do we do addition and subtraction in simple assembler? Well, maybe not so simple, but how do we do it in assembler? Well, addition and subtraction must be done within the CPU. One of the objects of an addition and subtraction must be done in the CPU. You can move one or the other value into the CPU and then you add them together. You can move them both into the CPU and then you add them together. Let's do the first very simple thing of adding two literals together. So what I'm going to do is in RAX, I'm going to move the number 100. Now I always like to use hexadecimal because it's much easier to see in the debugger. And then I'm going to add RAX, 200. And so you move one value into the CPU and then you can add a literal value or you can add a memory value. Now let's go ahead and save and build that. Okay, built just fine. Let's go ahead and debug it. Opening a terminal. And let's see this actually happen. So I'm going to scroll down to, now I always like to put a breakpoint on my very first no-op, that's why I've got that there, but I'm also going to put a breakpoint on line 25. Let's run it. I'm now going to click run again because I want it to continue to the next breakpoint. And if we go to our little terminal here, we can see the welcome to my program printed. And here we go. So this is our move. So we're going to be taking a look at RAX here. Let's move 100 in there. There you can see our 100 right there. Let's step over the next one, and now it's 300 hexadecimal. And the decoded decimal value of 300 hex is 768. So that's our very first simple little addition. And you can do the same thing with subtraction. So let's go ahead and now subtract something from that. I'm going to subtract from RAX 100H. It should now go back to 100. Let's save and build it. Built just fine. Let's debug it. Our breakpoint should all be set up the same. Okay, again, we're looking at RAX. So let's step over. It's got 100 hexadecimal. We're going to add 200. We're now going to subtract 100. It now goes to 200. So very, very simple to do with literals. But how do we do it with actual memory labels? Well, if you watch the how to create variables and how to move them in and out of the CPU, that should actually be pretty simple for you. So let's go ahead and create a quad value. I'm going to call this integer 1, and I'm going to say define quad 200H. I'm going to say then integer 2, define quad 55H. So we've got integer 1 and integer 2. They're both quad values, which means they're 8 bytes, which is the same size as RAX. And what I'm going to do is I'm going to move into RAX integer 1. Now the square brackets around the variable name means go out of memory and grab that data and put it into RAX. Then I'm going to say add RAX, comma, and I'm going to say integer 2. One of those values must be into RAX first. No problem. Now, let me show you an example of what won't work. I cannot say add integer 1 integer 2. That just won't work. You cannot add two values from memory. One of those values must be put into the CPU first. That's what this code here does. This just won't work. And you can see invalid combination of opcode and operands. So let's go ahead and delete that. Let's rebuild our project. Let's debug it. Are you noticing how fast we're going here? Linux really allows that to happen. Okay. So our breakpoints have changed a little bit. Let's start that over. I'm going a little bit too fast. Let's start that over. Let's clear all of our breakpoints. Let's jump right over here, put a breakpoint on line 32, run it. Okay, so we're going to move integer 1 into RAX. What is integer 1? Integer 1 is a 200. Well, we already have 200 in there. You're never really sure what you're going to have. So let's step over. 200 is there. We're going to add integer 2. What is integer 2? It's a 55, something a little bit different. And now it's 255. So we added. Subtraction works exactly the same way. I could demonstrate it to you. I would suggest you try it yourself. So we did literals and we also did memory labels. There's also something else you can do, and that's the thing called increment and decrement. Increment means add 1, decrement means subtract 1. So I'm going to decrement RAX, and then I'm going to increment RAX. And we can see the results of that. So let's go ahead and make it. Let's debug it. Let's double check our breakpoints. Now if I wanted to clear all my breakpoints and start over, I can go ahead up to breakpoint, and now I would really like it in this debugger if there was a way to clear all breakpoints in the program. I haven't found one yet in KDBG, so I just manually, I don't put a lot of breakpoints, but I just put just enough to be able to get by. So let's go ahead and run this. Run again to jump down here. You can see RAX is 255. Let's decrement it, step over, and now it's 254. Let's increment it, step over it, and it now has 255 again. So increment and decrement is a quick way to add 1 to a register within assembly language. So that's really it. That is increment and decrement. Now, before we leave, because this video is just about done, simple arithmetic is so simple, is that you need to be able to know what actually happens to the flags, to the status flags of the CPU when you do arithmetic. So to demonstrate that, I'm going to go over here and I'm going to move into RAX a very large number. F, 16 nibbles, 64 bits, all the bits are turned on. We're going to take a look at that in the debugger. But what happens if I fill up the entire CPU with ones? What happens if I increment, or what happens if I add to RAX 1? What actually happens? Well, let's take a look. So I'm going to go ahead and build that. Built just fine. Let's debug it. Let's move down here. Let's get rid of our decrement. Jump right down to that move all F's into RAX. Okay, right now RAX is 255. Let's step over. It is completely filled up with data. If it was signed, that would be a -1. We're going to ignore that, but it's completely filled up with data. And let's see what happens when I add 1 to RAX. It actually went to 0. It wrapped back around. It had the maximum value in there, and when you add 1, everything turns off, but we lost a bit. Something should have gone into the 65th bit, but the CPU isn't a 65-bit processor. So where did that bit, that lost bit, that overflowed, where did that go? Well, I'll tell you where it went. It went into the carry flag. How do we know that? Well, let's scroll down here, and you can see our instruction pointer flag. That simply changes every time we execute a line of code. that would actually change. And I'm going to scroll down here, and here is our E flags. E flags contains the carry bit. Now, the way that it's shown here, Windows is much easier in this situation because it actually will show the carry flag, but we can look at the E flags right here, and we can see that something changed. Well, how do we know? Because it's red. Now, you have to know the exact position of the carry flag in KDBG to take a look at, is it a 1 or a 0? But there's also something else you can do. You can check to see if the carry flag is set. Now, how can we check that? Well, there's a little command called jump if carry flag is set. Now, this is the first time we've seen any kind of a transition of control or change in control, but jump carry means I want to jump to a label in the program, and I'm going to call this a carry label. I can call it anything I want. I'm going to create that label down here. Now that label is the, in this case, carry label followed by a colon. That's like a go-to in C or C++ or COBOL or Fortran for that matter. I'm going to jump to that label if the carry flag has been set. Now what I'm going to do is I'm just going to put a no-op in there. If the carry flag was not set, I'm going to put a no-op right after it. So if the carry flag was set, which means we lost some data, I'm going to jump to carry label and do nothing. We're just doing this in the debugger. If the carry flag was not set, it's not going to jump. It's just going to go to that no-op. Now we might have something here that is going to do something like print an error message. Instead of just doing a no-op, I'm going to actually then jump to end all, and my end all label is going to be right here. So that's going to jump around my carry label code. So I might actually have something in there. Let's do that. I'm going to create a little string up here called carry error, define byte, error in addition. I don't know, I could put anything there. So that is my little label or my little string saying that there was an error in an addition. And down here in the carry label, I'm going to keep that no-op there. And how do we actually print that? Well, using the Komanetsky functions that I provided you, I'm going to push the carry error. I'm going to call print string, and I'm going to call print end L. And print end L is basically a \n. So it'll now print it. Print that error that we had a carry problem. Okay, let's go ahead and build that. Let's actually run it. So instead of debugging it, I'm going to say /main. And you can see right here, error in addition. So the carry flag was set. We jumped carry to the carry label. The carry label, the first statement it did was nothing. And then it went ahead and printed the carry error. Now let's change this. Let's comment out our add. Or actually, we could just put a 0 there. Let's put a 0 there. Let's build it. And let's run it. Notice the error in addition did not occur because we actually didn't do anything. We added 0, which did not create a carry bit. It did not go outside of the 64 bits of the RAX register, so the jump to carry label did not execute. We could put something else here. Let's say add OK, define byte. The addition worked. And I'm going to print the add OK. I'm going to call print string. Let's build that. Let's run it. And you can see the addition worked because the jump carry did not occur, so it printed the add OK. Then it jumped around this block of code, which is going to print the error message. And it went to the end all, and the program ended. We can debug this. It's kind of fun to debug. And it's also very valuable. Now, we've put like almost no comments here because these are very basic statements. You can pretty much see everything that we're doing here. What I would probably do is I would probably put a comment here that says jump if there was lost data. Very nice comment. And now let's debug it. Let's take a look at our breakpoints. So let's clear that breakpoint. I'm going to put a breakpoint there. Everything's cool. Let's run it. We're watching RAX. Let's run again to jump to the next breakpoint. Okay, so it's going to put all F's in there. If we go down here and look at the E flags, the E flags register hasn't changed. It's the same. Let's watch what happens when we add 1. Boom, turns red. Now again, the debugger isn't really good at, in the debugger in KDBG in Windows, it is better in this case. It doesn't show the carry, but we're going to jump carry, so we're going to press step over. So it jumped to the carry label. It does the no op. I'm going to put a breakpoint right there. I'm going to click run, and you can see right here, error in the addition. So that's how addition, subtraction affect the flags. Now, if this was a signed addition or subtraction, it would have also updated the overflow flag, but we were just dealing with unsigned. So instead of checking the carry flag, we might want to check the overflow flag. We'll be talking about that more in future videos. So that's it. Simple addition and subtraction, increment, decrement, and using the carry flags to check our arithmetic. Hope to see you at the next video.